Hello everyone, Vishal sir is here and we are dealing our very important chapter, that is first chapter of the ninth class science, matter in our surrounding. And in this chapter we know that there are five states of matter. We know what is matter. Anything which has mass and occupied space is known as matter. And there are five types of matter: solid state, sorry, there are five states of matter, and that are solid state, liquid state, gaseous state, plasma, and Bose-Einstein Condensate. So before that, in the previous part we seen about solid state, gaseous state, liquid state. Now it's the time to know about more about plasma and Bose-Einstein Condensate. So my dear student, please see it carefully and listen it carefully. I have some slides for you. So we will deal first plasma and after that Bose-Einstein condensate. So plasma is an ener- energized gas, energetic gas made up of positive ions and free electrons. It is what? It is a energetic gas and which is made up of positive ions and free electrons. So when we are providing current to it, it conducts electricity. It conducts electricity, and due to this electricity, it forms around it magnetic fields. You can see this magnetic field around this bulb. Okay. Now plasma don't happen regularly on Earth. Keep in your mind, my dear student, plasma don't happen regularly on Earth. For plasma to occur, a very special environment has to take place. It needs a very special environment, then only it can happen regularly on Earth. Okay. So examples of plasma are man-made examples. The first example is our LED light. Okay. So fluorescent light bulbs, electricity flow through the tube when the light is turned on and charges up the gas. When we are providing electricity to this bulb, whatever the gas inside in it, it charged up and it glows, and that phenomena is known as fluorescent phenomena. Okay. Neon signs. Okay, neon gas are there, helium gas also is there, which is used for the lights. Okay. Tubes filled with gas that have charged up gas because of electricity. It glows a special color depending on the gas. Okay. If the gas are different, then it produces a different types of colors. I hope that you are understanding about the plasma and its example. So natural, what are the natural plasma? That tube tube lights, neon signs are the man-made plasma example, but the natural examples for the plasma is stars, big balls of gases at big balls of gases at a really high temperatures that creates plasma. At high temperature, the big balls of gases at really high temperature it produces great plasma. It means it's showing light. Okay. Northern lights, these are nothing but natural plasmas. I hope that you understood about the plasma, and we know that plasma is the fourth state of matter. Plasma is the most abundant form of matter in the observable universe. Plasma was identified until the 20s. So keep in your mind these things, my dear students. Now we will try to know that more about Bose-Einstein condensate. So attention for the Bose-Einstein condensate, a state of matter in which separate atoms or particles are cooled. A state of matter in which separate atoms or particles are getting cooled to near absolute 0 degree Celsius. Okay, separate atoms or particles are going to be cooled in the state. Okay, and that state is known as Bose-Einstein condensate, and it is also known as BEC. It is the fifth state of matter. It is a state of matter made by humans. It is a state of matter. It is made by humans. Okay, rotating BEC. BEC stand for Bose-Einstein condensate. Could be used as a black hole that allows light to enter but not to escape. See here, rotating BEC, Bose-Einstein condensate, could be used as a black hole that allows light to enter but not to escape. That it can allow to enter it, that light allow to enter inside but not to escape. Okay, this form of matter was first predicted by Albert Einstein in 1924, who was based on the quantum formulation of physicist Satyendra Nath Bose. Okay, but didn't have the necessary equipment to do. So this things comes from the Albert Einstein and Satyendranath Bose, and due to this only it is known as Bose-Einstein condensate. Okay, so this is the pictures of Bose-Einstein. This one, my left hand side, it is Satyendranath Bose, and here my right hand side, Einstein, Albert Einstein. You can see the picture, but it was finally created in 1995 by two scientists named. So, my dear students, it was finally created by the two other scientists, and the name of that scientist is Eric Cornell. Okay, and second name is Carl Wieman. So, an example of BEC is a neutron star. For example of BEC is neutron star, and this neutron star is looking like this. So, in a neutron star, the atoms are crammed very close together, so close that they behave as a single atom. You can see the picture once again. They are closing to each other, and they are seeing that close to each other, and they are showing single picture. Okay, so close, so close that they behave as a single atom. They are some of the densest object. Okay, densest object in the universe. It was calculated that if a baseball was made of the material that comprises a neutron star, it would weigh around 20 trillion kilograms. Okay, I hope that you understood this about the Bose-Einstein condensate. And another example for the Bose-Einstein condensate is the 2000 rubidium atoms. Okay, 2000 rubidium atoms which were cooled down and behaved as one atom 10 seconds. Okay, it 2000 rubidium atoms, if we are going to cool them, they behave as a single atom. uh, uh, the time given, that is up to the 10 second. Okay, liquid, another example for the Bose condensation is liquid helium is also an example, and it loses all viscosity at below 2.2 Kelvin, and it becomes a superfluid. So this is the speciality of the Bose condensated. When we are separate atoms or separate particles going to be cooled down, they are showing that they are single one. Okay, and this is the fifth property, is fifth state of matter, and which is made by human. I hope that you understood these things. Thank you. Have a nice day. Stay home. Stay safe. Thank you. Bye bye.